Hello and welcome to Aditya classes. Today we'll take up a question of linear problem and we'll try to solve it using Simplex. Now this is a question that has been shared by a fellow learner. This is a special question. When we'll start it, we'll see that we get a b of 0. Now what happens is, we have b, we have theta. So we decide upon theta. The least positive of the theta, least positive of the theta is selected as outgoing variable. The most positive from here, net evaluation row, which is Cj minus Zj in case of maximization. For minimization, this becomes Zj minus Cj. So from net evaluation row, I take most positive, and from theta, I take least positive. Now, if we look at this case practically, what happens is, if I have b as, let us say 8, 1 and 0, and we try to find out theta. Let us say the key column elements over here were maybe 4, 2 and 10. Now if we have this kind of situation, theta would be, this is key column, let us assume. So theta would be 8 divided by 4, that is 2, 1 divided by 2, that is half, and 0 divided by 10, which will be 0. Now technically, if we were taking the least value, then this 0 would have been my value. But if, let us say this is negative, so this becomes negative. If we had a rule of least value, in that case minus half would be least value. But we are not considering negative values, so we take least positive. In case of least positive, this becomes my selected value. What about 0? Is 0 not less than 2? Can we say that 0 is a negative value? Now this is a catch. 0 is definitely less than 2 and 0 is not a negative value. So what do we do in this case? If it so happens that we have such kind of situation where b becomes 0, if we end up in a situation where b becomes 0, then we'll get a 0 which technically is not negative and also least, so it should be selected. But our condition is least positive, hence 0 is not selected because it is technically also not positive, but then it is not negative. So this is a catch, this is a confusion state. What we do in such cases is, instead of 0, we assume this value. Instead of 0, I'll assume this value to be epsilon. This is epsilon. What is epsilon? It is very small. Very small. In fact, instead of very, I can say infinitesimal. It is not even very small, it is infinitesimal value. It is infinitely small value. It is almost 0, but it is not 0. Hence, this becomes epsilon, which is a very small value, but it is not negative. Hence, it is positive. So this value will become epsilon upon 10. Now, what is value of epsilon? I am not sure, but definitely it will be less than 2 because epsilon is very small value. This is how we break this, we resolve this issue of 0. So the idea is, if at all you have a 0 in your b, it will give you a 0 in your theta. In order to avoid it, what we do is, we replace the 0 by epsilon, which is a very, very small positive value. Hence, we can get theta, which now will be less than 2. Earlier 2 was the least positive, but now this will be my least positive. So let us get on with this question and we'll see if we come across 0. So I'll remove this and we'll start with our question, our IBFS and all. So we have the problem in a canonical form. Let us convert it into standard form first. Standard form would be removing the inequalities and replacing these inequalities appropriately by either a slack or a surplus variable. If you are making use of surplus variable, you will be making a use of artificial variable also along with it. So let me convert this canonical into standard form. What happens? 2x plus y plus 2z, this is less than, so I will add something. Because this side is less, left hand side is less, so I'll add something. This would be 5x minus 2y minus 2z plus another slack is equal to 0 this time. Then last one is, sorry, this one was fourth. This will be S3. And then I'll remove this, otherwise it will create confusion. This is third constraint. Second one is this, x minus 4y plus 2z plus S2 is equal to 0. Then we have a 5x minus 2y minus 2z plus S3 is equal to 0. And then we have z max is equal to 4x minus y plus 2z plus 0 S1 plus 0 S2 plus 0 S3. This becomes our formulation. Canonical converted into standard. Of course, still x, y and z are greater than or equal to 0. Can we have our IBFS from this standard form? For IBFS, what do we do for IBFS? We put all decision variables, that is x, y and z, as 0. If you make all decision variables 0, first constraint would give you a S1 is equal to 6, second one would give you S2 is equal to 0, third one would give you S3 is equal to 4. Have I written this correctly? 5x minus 2y minus 2z. This one is 4. Let me check it once again. 4, 1, 2. 4 minus 1, 2. 2, 1, 2. Then we have a 1 minus 4, 2. And then there is a 5 minus 2 and minus 2. This will be my IBFS. Now that I have my IBFS, can I move on to my first simplex table? First simplex table would be B and theta. Then we have 3 slacks and 3 variables, S1, S2, S3. X, Y and C. Their respective contributions are 4, minus 1 and 2. 4, minus 1 and 2, 0, 0 and 0. Here I have IBFS of S1 is equal to 6. S1 is equal to 6. S2 is equal to 0 and S3 is equal to 4. And contributions of S1, S2, S3 are 0, 0 and 0. Now can we fill in our constraints? There will be 2, 1, 2. Then we have a 1, minus 4, 2. Then there is 5, minus 2 and minus 2. Here we have our identity of S1, S2, S3. 1, 0, 0, 0, 1, 0, 0, 0 and 1. These are the contributions. We have ZJs. ZJs are sum product of the respective column with contributions. column with contribution. So everything will be multiplied to 0. 2 multiplied by 0 plus 1 multiplied by 0 plus 5 multiplied by 0. Now whichever column you may take, it will be respectively multiplied by 0. 1 multiplied by 0. So we'll get a 0 to start with under every column. Then because this is maximization, I'll go for Cj minus Zj. Cj minus Zj. 4 minus 0, minus 1, 2, 0, 0 and 0. This is the most positive, giving me my key column. Now divide B by key column. We get 6 divided by 2 as 3. Now 0 divided by 1. 0 will be replaced by epsilon. 0 will be replaced by epsilon. So this becomes epsilon divided by 1. And this will be 4 divided by 5. So 4 divided by 5 is smaller than 3. But then epsilon is infinitesimal value. It is very tiny, very infinitely small value. So this is epsilon. So my least positive value is epsilon, giving me my key row, and the intersection will give me my key element. What is the importance of key element? While moving these values to our new matrix, the key row, complete key row is divided by key element. So we'll divide this complete row by 1 to get our new modified key row. In this case, everything will be divided by 1. So as such, there will be no change. X, Y, Z, S1, S2, S3, B and theta. 4, minus 1, 2, 0, 0, 0. Now S2 is moving out, instead X is coming in. So we have S1, X and S2. S3, sorry. S3 is intact. Divide all by 1, they will remain same. 1, minus 4, 2, 0, 1, 0. And epsilon divided by 1 would give me an epsilon. Fine. This is my modified key row. Now we need to bring the first row and third row. The formula for this is old row minus key column element I multiplied by modified key row. Old row, we are transferring first row. So this will become, I will become 1. Old row, 2, 1, 2, 1, 0, 0, 6. Minus key column element 1. Key column, this is key column. This is key row. Key column element 1. It is 2. Then modified key row would be, modified key row is this. What is this? 1 minus 4, 1 minus 4, 2, 0, 1, 0 and epsilon, giving me values of 2 minus 2 would be a 0, 1 plus 8 would be a 9, 2 minus 4 would make it a minus 2, 1 minus 2, 0, 6 minus epsilon. Now 2 multiplied by epsilon, this is almost 0. So this will be 2 into 0. So 6 minus 0 would be 6. So this will be 6 only. So what do we get? We get a 0, 9 minus 2, 1 minus 2, 0 and 6. And if we try to transfer the other row, the other row would become third row. So this will not be key column element 1, rather it will be key column element 3. What do we have? 5 minus 2. 5 minus 2 minus 2, 0, 0, 1 and 4. And key column element 3, that is 5. So we have a 5 minus 5, making it 0, minus 2 plus 20, 18, minus 2 minus 10, minus 12, 0, minus 5, 1, 5 multiplied by epsilon would be almost 0. So this will be almost 4. So we get 0, 18, minus 12, 0, 5, 1 and 4. This will be minus 5. So we have a 0, 18, minus 12, 0, minus 5, 1 and 4. We have S1, X and S3 with respective contributions of S1 is 0, X is 4 and S3 is 0. So what do we have? This complete row will be multiplied to 0. Whenever we are making a sum product of column, these elements will always get multiplied to 0. So these are irrelevant. Literally this is also irrelevant because it will be multiplied to 0. So all we have is this. 1 multiplied by 4 is 4. We have our Cj and Zj. Minus 16, 8, 0, 4, 0. So Cj minus Zj would be 4 minus 4, that is 0. Minus 1 minus 16 would be a plus 15. Minus 1 minus 16, it will be a plus 15. 2 minus 8 would be a minus 6. Then we have a 0, minus 4 and 0. So the most positive is plus 15, giving me my key row. And let us find out theta. 6 divided by 9 would be a 2 by 3. Epsilon divided by minus 4 would be a negative value, hence it will be rejected. 4 divided by 18. 4 divided by 18, or I can say 2 divided by 9. So 2 divided by 3 and 2 divided by 9. Definitely this is smaller value. So this becomes my key row. This was our key row. This is our key row. This is our key element. So let us transfer this table to the new table. This is table 1. Here we have table 2. Now we are up to table 3. We have S1, S2, S3, X, Y and Z. Contributions are 4, minus 1 and 2. 4, minus 1 and 2, 0, 0, 0. S1, outgoing variable is S3. So instead of S3, now I will be having a Y. So we have S1, X and Y. Respective contributions being 0, 4 and minus 1. Now we need to transfer all these to our new table. We'll divide all these values by 18 to reach to our new table. 0 divided by 18 would be a 0. 18 divided by 18 would be a 1. Minus 12 by 18, or we can say 2 by 3. Minus 2 by 3. And this will be 0, a minus 5 by 18, and a 1 by 18, and last one would be a 4 by 18. So this becomes our key row. Now, can we transfer the remaining two rows using this same formula, which is old row minus key column element I multiplied by modified key row is equal to new row. So I need to transfer my first row. In that case, it will become key column element will become first element, that is 9. When I transfer the second row, it will become minus 4. So now we have attempted many questions of simplex and we have transferred a lot of tables from one table to another. So I will just put up the values over here. You can transfer them using this formula. So here are the new values after transferring them to table 3. Now can we find out Zj? All these will be multiplied to 0 at some point of time. All these will be multiplied at some point of time to 4. All these will be multiplied at some point of time to minus 1. So we'll get 4 multiplied by 1 plus minus 1 multiplied by 0, making it a 4. This will be minus 1. This will be minus 8 by 3, and this will be plus 2 by 3. Thereby making it minus 6 by 3 or minus 2. Then 4 multiplied by 0, minus 1 multiplied by 0. This will be minus 4 by 9. Minus 4 by 9 and plus 5 by 18. Plus 5 by 18. Or we can say minus 8 plus 5 by 18, making it minus 3 by 18. And last one would be 8 by 9 minus 1 by 18, making it 16 minus 1 by 18. 8 2s are 16, 9 2s are 18, 15 by 18. 15 by 18. Then we need Cj minus Zj, because it is a maximization case. So 4 minus 4 would give me a 0, minus 1 minus 1 would give me, minus 1 minus minus 1 would give me a 0, 2 minus minus 2 would give me a 4, 0, 3 by 18 and minus 15 by 18. If we look carefully, we'll see that this is negative, this is 0, this is 0, this is 0. There are two positives. Of these, this is very small, this is the most positive. So I get my key column under minus 4. I have my key column, that is incoming variable is z. And what about outgoing variable? Theta. 4 divided by 4, 1. 8 by 9 divided by 0, 8 by 9 divided by minus 2 by 3, something negative. 4 by 18 divided by minus 2 by 3, something negative. So these cannot win the race. The least positive is theta, that is S1. S1 is outgoing variable, Z is incoming variable, and this is my key element. So can we transfer this to our new matrix? X, Y, Z, S1, S2, S3, B and theta with contributions of 4, minus 1, 2, 0, 0 and 0. S1 will be replaced by Z. So we have Z, X and Y. And who is the key row? First one is the key row. So we need to divide complete key row by key element, that is 4. So we get a 0, 0, 1, 1 by 4, half divided by 4, half divided by 4, making it 1 by 8, And minus half divided by 4 would be a minus 1 by 8. 4 divided by 4 would be a 1. So this is transfer of key row, and then we can transfer the remaining rows also using that same formula. What was that formula? Old row minus key column element I multiplied by modified key row is equal to new row. So once again, I'll transfer these values. You can solve these values by yourselves. It will be a practice for you, and I'll fill in these values directly. So here is the transferred table. Now we can go ahead and find out Zj. We have Cj's and Zj's. Z is contributing me 2, a contribution of minus 1 from Y and contribution of 4 from X. So we'll get a 4 minus 1, 2. This will be 2 by 4 plus 4 by 6, and this will be minus 1 by 6. So we have a 2 and 4, 6, minus 1, 5 by, sorry, this was 4. So we'll have a 12, 3 2s are 6, 4 2s are 8 minus 2. So 6 and 8, 14 minus 2, 12 by 12, giving me a 1. And then we'll be having 2 by 8. Then there is a minus 1 by 9. Then there is a plus 7 by 36. Making it, we can say it, 36, 72. 9 2s are 18 minus 9, 8s are 72 plus 14, making it 18 minus 8, 10, 24. 24 by 72 or 1 by 3. So we get a 1 by 3. And then we have minus 2 by 8. Last one would be minus 2 by 8 plus 20 by 36, and last one being plus 1 by 36. 72 becomes LCM, 8 9s are 72, 9 2s are 18 plus 40 plus 2. So this becomes 22 and 2, 24. 24 by 72 once again, giving me a 1 by 3. So what will be Cj minus Zj? What do we have as Cj minus Zj? We have 4 minus 4, 0, 0, 0, minus 1 by 3, minus 1 by 3. Hence, at this point we can say that we have reached the optimum solution. This is the best possible solution because all values are all net evaluation row. This is our net evaluation row. All net evaluation row values are either zeros or negatives. Hence, my solution at this point of time is x is equal to 14 by 9, y is equal to 8 by 9, and z is equal to 1, giving me a z max of 4 multiplied by x. 4 multiplied by x would be 56 upon 9, and minus 1 multiplied by y. 4 multiplied by x minus 1 y, minus 8 by 9, and z is 2z. So making it plus 2. If you take LCM as 9, this will become 18. Giving you a value of 9. 56 plus 10, it is 66. So we have a Z max of 66 by 9, and X, Y and Z values are such. So this was a case where we were getting a B value of 0. Whenever you come across a B value of 0, you can put an epsilon. Now, how does this epsilon help you? You could have straight away gone and taken that 0 as smallest value. Why do we need to put that epsilon? Why are we putting that epsilon? Because if it so happens, I'll remove something over here. So why are we putting this 0 as epsilon? Because if it so happens that you have a B of this kind, 6, 0, 0, 4, and then your key row has values something like, let's say 8, 3, 7, minus 2. And now if I go ahead and find out theta, this would be 6 by 8 or 3 by 4. This would be negative. So this is rejected. 4 divided by minus 2 would be a minus 2, which is rejected outrightly. We need least positive. Now in this case, if we go ahead with the rule of selecting 0 as my least positive value, then which one of these 0 is your least positive value? Because this is 0 by 3 and this is 0 by 7. 0 by 3 is 0, 0 by 7 is also 0. So which of these two is least? This I cannot decide. So what I am doing over here is just like the big M concept. What was big M? It was an infinitely large positive value. It was such a large positive value, but we were not putting as a infinite. We put it as M. We do not call it infinite because infinite upon 10, infinite upon 20, 4 infinite, 5 infinite, everything is equal. Everything is infinite. Hence we call it M. Now I can say that M by 10 and M by 20. M by 10 is larger. 4M and 7M. 7M is larger. 4 infinite and 7 infinite, everything is infinite. Similarly over here, 0 by 3, 0 by 7, everything is 0. But now, when I call it epsilon, it is a very small value. And of that small value, this time I am making 3 parts, epsilon by 3. This time I am making 7 parts, epsilon by 7. Which one is smallest? Now I can very clearly say that this one is smallest. This is the reason why whenever we come across 0, yes, we could have selected this 0 in this case outrightly. It was the only 0. But it might so happen that you have 2 zeros. Then how do I decide which one is smallest? What I do is, instead of those zeros, I put epsilon. Now I can say that epsilon by 7 is the least value. This is the reason behind putting this epsilon and not calling it 0. In fact, this is the very same reason why we put a minus M in greater than inequality, big M method. We put a, not minus M, we put a M, big M method, a very big value. We do not put an infinite because infinite cannot be operated upon, but big number can be operated upon. Big numbers can be compared. 4M is more than 3M. That is the idea. So this was a question that was forwarded to us by a learner, and this is the solution. Here we can divide it. This is our table 4. These are my solutions. This is my solution X, Y, Z and Z max. So this was a special case of simplex where we were getting a B of 0, hence leading me to a theta of 0. We'll take up some more questions on simplex, on linear programming, on dynamic programming, on goal programming in the lectures to come. Until we meet next time, do take care. Thanks for watching. Bye-bye.